Cubane C8H8 is a fascinating synthetic hydrocarbon with unique properties. The 8 carbon atoms of the molecule are arranged in the shape of a cube. Philip Eaton and Thomas Cole synthesized cubane for the first time in 1964. The synthesis of Eaton and Cole starts with 2-cyclopentanone. The cube is built by a Diels-Alder dimerization, a photochemical cycloaddition, and a Favorsky rearrangement reaction. The last synthesis step is a decarboxylation. This is a simpler synthesis of cubane that starts with cyclopentanone. One intermediate product is the tribromocyclopentanone derivative. Again, the last edge of the cube is built by a rearrangement reaction. This is the space-filling model of cubane. Its melting point is 134 degrees Celsius. Cubane has a very small surface and the intermolecular bonds are weak. That makes it a very volatile compound. The carbon atoms are sp3 hybridized. They usually have a bond angle of 109.5 degrees. That is different from the 90 degrees angle in a cube. The maximum electrodensity of the carbon-carbon bonds is not along the edges but above. Cubane has bent bonds that are sometimes called banana bonds. They help reduce the ring strain. Cubane still has a high strain energy of 169 kilocalories per mole. Cubane can be converted to other compounds by metal-ion catalyzed intermolecular rearrangement reactions. Cuneane can be produced with a silver or palladium catalyst. Syn-tricyclooctadiene can be made with a rhodium catalyst. Heating it to 50 to 60 degrees Celsius converts it to cyclooctatetraene, a non-aromatic compound with a bathtub structure. One of the applications of cubane is as rocket fuel or as fuel additive. Combustion of cubane releases the energy from the oxidation reaction plus the strain energy from the destroyed cube. That increases the temperature and the pressure in the engine and increases its performance. Cubane is also interesting as a basic structure for pharmaceutical compounds because it has the same size as benzene. As the new Cubane C32H8 is another interesting molecule with a cube structure that has not been synthesized yet. One potential path to this compound is the metal-catalyzed alkyne metathesis reaction. You can check out the links to the scientific articles in the description field, and you can check out my other videos from the chemistry series. Thank you for watching.